Okay, so my understanding of this is 11, 13, 14, 15. We need some guidance or, a nuclear bomb just to get rid of those questions. One of the two, okay? The nuclear option has got to be off the table, however. Okay, so now, here's the thing. I appreciate the fact that the wheels on the bus fell off and you guys all told me about it. Okay, it's really horrible when you're just dragging the thing along. But as you're going through, let's just check these. If we can bowl this out to 11, wherever that is. It is here. Tell you what, we'll go from 11. Yeah, we can look at 9. Let's chat about these. Co-terminal. And I think the thing that's really tough is I'm doing them in radians, right? I'm using the R word. So be advised that 1 revolution in radians is 6.28, okay? Or if I leave pi in there, it's 2 pi. Okay, so sometimes when people go through there, they're trying to do other things. As soon as you see that pi there, we're assuming radians, especially, here's the thing that might be the kicker on it, is the fact that, I don't know, we don't have that degree sign there. Okay, that way I don't step on it. Okay, now, when we're looking at this today, find a coterminal angle to the angle 27 pi over 50. Now, this is one of those nice things about knowing about coterminals. I don't give you a limitation about what they're going to be. Okay, I didn't say, well, it's this. So you got to kind of work on all of them. And when I'm looking at this 27 pi over 50, I'm thinking, okay, coterminal with 27 pi over 50. This is already over 50 and it's positive, and I'm thinking, all right, if it's 27 pi over 50, I can take away a 27, and I got 361 pi. And I'm just thinking about what else could be coterminal with that. And if you recall, I got 361. Now, this should have been pi. Maybe I should rewrite it. If I just check this one, 361 pi over 50, if I'm going to divide a full revolution, how many 50ths are in a full revolution? Remember, it's because of the fraction. How many 50ths are in a full revolution? It's 100 50ths are in the full revolution. That's why I'm looking at this, and if I divide it by 2 pi, that's the same as dividing by 100 pi over 50. Are you okay with that? So I got 100 pi over 50. That's 2 pi. That's the same as, and again, I'm reminding you when I do this, why I'm just going to, in the future, just say, hey, we're just going to take 361 and divide it by 100. Okay, to find out how many revolutions there are. Does that make sense? Okay, so take your calculator and go 361 divided by 100. Okay, that's 3.61. And then I've got that 0.61, or subtract off the 3, I should say. So take your ants and subtract off the 3. And then I'm multiplying it by 100 because it's 60% of 100, 61% of 100, I should say. So it should be 61 times 100. Should give me a 61. I don't know why I can't see the difference between plus and 100 times. So this is the same. This coterminal angle is 61 pi. Okay, so if I'm thinking about it, if I'm over here at 61 hundredths, so I'm down here. Okay, that's 50, and I'm down here at 61 pi 50ths. Okay, are you okay with that? 61 pi over 50 is what A is. Yes or no? Now, if it's no, we got to speak up, because I'm going to do it with the next 5, what I just did with that. Yes?
So you literally just take the bottom number, multiply by 2,
divide it right in. I double it, but I got rid of the pi. Didn't notice how I got rid of that pi. Because it made sense, because it does it in the fraction.
double the bottom, get rid of the pi.
Yep, if it's there. But now that rule falls off. No, it won't fall off at all on these, on the ones that I provided. Okay, but remember, the purpose of me doing this, I'm looking for 27 pi over 50. Okay, and they're all 50s. And they all seem like they've got it. Now, Here's the thing. I want to show work with this. I just don't want you to take the calculator and go, well, you know, this one's this one's this will be, you know, that value and that. So I just want to make sure you recognize what's happening as I'm doing it. Are you okay with the first one? In number 9, yeah. After I do that, I get my three times and then 61/100ths left over, right? In this part, I mean divide in this case. Oh, yeah. Now let's think of what that 100 was. It was a full revolution. Okay, that 100 is how many 50ths are in a full revolution, right? There's 150ths in there. After I finish dividing by 100, I multiply it back in. Now I have that 61. But really it's 61/50ths, right? It's 61% of a full revolution, so I put it in at 61 pi over 50. So I have to know I have to put that back in. Okay, does that make sense? But that's why I was able to come up with 61/50ths, 61 pi over 50. And I go from 100, I multiply the 100 back in, but then that's my top number, and my bottom number is the 50ths, and I plop on the pi because I divided it out at the beginning of the problem. Okay, so yeah, it was part, but I finished out the problem. I'm sorry. Okay, did I answer the question? Well, your question was I divide by 100, so I got 3.61, right? I subtract off the 3, and now I got 0.61. Multiply by 100, that's where I get 61, right? What do I do with that 61 after I did it? I put a pi to the right and slap a 50 underneath, and I'm done. So I just finished it out, okay? But remember that 0.61 is about full revolutions, and that's why I have to multiply it back by 100, not 50. Okay, clarification on that? Okay, now, that's my A and my B. When I'm looking at B, I'm just going to take my negative 224.39 and divide it by 100 because I just went through the work to show you why in the world I may be able to drop everything else out. So to talk about B, I've got negative 24.39 divided by 100 because I'm talking about hundreds, I'm talking about 50ths, and for the same reason I did 100 on the A, I'm doing the same thing for B. So I got negative 2439 divided by 100. And now I got negative 24.39. Okay. So I got 39. This is negative 24.39. Now I'm worried about 0.39 times 100. Well, the beauty of this is it's 100, so that's negative 39. So that's negative 39. Okay. I'm not even out of the first quadrant yet. Well, I'm out of the first quadrant. I'm sitting in the second quadrant on this one. Maybe I have a different thing here. So I've got this, and this is 50. This is 50 pi over 50. This is right now at 39 pi over 50, but it's negative, so I apologize for even writing it up that way because it's a negative 39. It's actually down here. It should roll that way. So this is negative 39 pi over 50. Not the same as 27 pi over 50. Are you okay with that? Yes or no? It's quiet, it's scary. Either we're getting it or we're not. So who's feeling comfortable with these? A little bit better. Who's feeling a little bit looser, like, geez, I don't know, it could go either way. Okay. Well, the negative 39 pi over 50 is a coterminal that's negative to negative 24.39 pi, 2,439 pi over 50. They're coterminal angles. I'm just trying to bring it back to less than a revolution, and if it's negative 39, I know it's not going to be 27 that's up here in quadrant 1. 27 pi over 50 is in quad 1, so I know that negative 39 isn't coterminal with it. And they're asking me to find the one that is. Okay. And each time I'm doing this, which is really nice that it's 100 because it goes a little faster. Okay, I got to get 69,827 divided by 100. Well, I do that, I got 0.27. Hey, I got 0.27. Well, that's going to be really nice. So this is 27 pi over 50. So that's why it's 27 pi over 50. It's not just because it's C, because you should pick C every time you don't know. Okay. All right. Nope. So the next one, this one's already 23 pi over 50, and I totally don't have to do anything with that, because I can totally tell you that 27 pi over 50 and 37 pi over 50, or 27 pi over 50 and 23 pi over 50 are different. And then this one is 73 pi over 50. Okay, so it's down over here, so that's going to be different than the other ones. So I only needed to check A and B, and then C, since I found the other one, I was golden. Does it make sense, the steps I'm going through? The fact that it was 100, I could have gone it without a calculator at all. I just wanted to make sure you knew what I was doing. Questions? Yes or no? Yeah. Yes, because if I'm coming through here, I'd be in the same spot as 27 pi over 50, and that correct. Okay, does it start to make sense a little bit? The hardest thing about this is because it's in radians. It's not because of the revolution stuff, because you guys were fine with revolutions when we did them with degrees, because we did that first day with coterminals. Okay, any other questions on 9? Don't get frustrated with them. Don't blow me off about them. If I didn't answer your question, ask me about it, or challenge me on my answer, because it's not about me saying something and you not getting it. Okay, it's about trying to make sure you get an iteration, a couple more iterations maybe, and seeing where we're going with our answers. Okay, so now in this next one, I think there was questions on 10. Was 10 okay once we do the reference angles with these? Okay. Did you notice they're the same numbers that we did? So once you did the work for finding the coterminals, the reference angles are just the positive angle value between the x-axis and the angle you found. Okay, so we'll just talk about these last ones. Since this was 27 pi over 50, this one, we'll talk about the last 3, and hopefully you'll be able to find the first 3, but just find the reference angle too. And the reference angle, if I've got this on in here, and this is going to be 25 pi over 50. Are you okay that that's 25 pi over 50? Okay, that's pi over 2, halfway through. And then my 27 pi over 50 is like right here. So this is my 27 pi over 50. So I've got 23 pi over 50 left to make 50. And that's where my reference angle comes in. So that's why it's the only one I'm picking. Okay. Questions about it? We're doing okay with reference angle? Going back to rotations again in 11. And that's all I'm doing is rotations in 11. So draw the following angles in standard position, then find the reference angle. Be sure to show the terminal ray and label the reference angle in your diagram. So first of all, are you fine with the fact that these are in degrees right now? At least this one is. Okay, and enable for me to work with it, it's negative, so it's coming out and it's going clockwise. And I pop this in my calculator, okay, to help me out with this. This is negative 2587.62. Now, I'm going to divide by 360, full revolutions, okay? And I got negative 7.1878 in that full revolutions in my calculator. Well, I'm going to get and take off everything to the left, because I'm only interested in the fractional portion, the stuff after the decimal. So now I'm going to add 7 to it because it was negative. And now I'm multiply by 360. And I get 67. Okay. Now, I get a negative 67 from here. When I multiplied that up, it was negative 67.62. But remember, it's a reference angle. And reference angles are positive angles between the terminal ray and the x-axis. So that's why it's that value. I just took the negative off. Are you okay with this one? Happier with 360 versus 2 pi. Here's the thing. How often have you worked with radians? Like, very rarely at all. Did you know that you have to set your calculator up differently to work with radians? Okay. That's another thing. Have you ever seen degree in your calculator? The degree and then a rad in your calculators? And people thought, dude, that must be a tubular numbers and like, totally like surfs because it's radical, right? No, that's radians, degree. Your calculator needs to be set up specifically in working with those values. If you set it up incorrectly, and out of the box, your calculator, your graphing calculator, is already set up for radians. So if you walk into ACT, SAT, or even the MCA, when they clear your calculator, and you didn't know that it starts working in radian right away, and you've been working in degree the whole time, you will correctly do problems, but give me the wrong answer because you are using the wrong measurement system for angles. So you got to know the difference, and that's available in mode. Just right now, just look at your mode in your calculator, just so you know right off the bat. Do you see that right under, you go normal, float, radian, over a degree. Everything on that left side of your calculator, that's how it is set up out of the box. You have to know to be able to flip it in, back and forth between radian and degree in order to successfully work with these problems, okay? And they don't care to tell you. Part of that test is knowing if you're working with degrees, it's in degree. If you're working with radians, it's in radians, okay? And you've got to know that. Other questions on 11, on the reference angles? Yes, no, any other ones, or all of them? Which, B? E? Okay. So when we're looking at E, I have in radians on my key, and people are like, well, geez, how do you know? Does it have a degree sign? Okay, does it have a degree sign? Now, once I know that, I've got to be thinking, okay, it's in radians. And without pi in there, I know 2 pi is what I'm going to divide by. Again, I have to be careful about my calculator because I've got at least a little less than 6 full revolutions going on here because it's 37. Okay, because 1 revolution is 6.28. So when I'm looking at this, I'm going to take 37.603 divided by, in my calculator, this. Now, please notice I put in the parentheses because your calculator, unless you are one of the ones with the horizontal fraction bar, will take this entry in your calculator like that. Your calculator will read that automatically as 37.603 divided by 2 times pi. Okay? Oops. You got to know what your calculator is going to do with its evaluation. So now I got 37 pi, second quit here. So today I got 37.603 divided by 2 pi. And that's going to give me my 5.984. Okay, 5.9847. I'm going to take off the 5. I got that 0.9847 ... in my calculator. Okay, and I'm going to multiply by 2 pi. Okay, because that's the revolutions I divided by, so I'm going to multiply back by 2 pi. And I get my 6.18 for 0.9847 times 2 pi. I get 6.187. You okay with this so far? It's almost a 6th revolution, right? It's almost 0, except it's not. So I'm short. Okay, I know a full revolution is 2 pi. So I'm going to take my 2 pi in my calculator, and I'll show you what I'm doing. I'm subtracting off my answer. So I'm going to take 2 pi in my calculator. I'm subtracting off 6.87 to get 0.96111. Okay, well, that's where my reference angle came from. Let's move that stuff up. Okay, so you can see him back there. Novotny, you okay? Didn't want you to hurt your neck. Okay, so are you okay with how I came about my reference angle? And how I was able to tell that I'm working in radians versus degrees just by the subtle difference of the symbols they're giving me. And if there is any question, I can clarify some of those things. Unless, I tell you at the beginning, everything is written as I expect you to know them from based on symbols in the test, and then you've got to read it on your own. Okay. Any other questions on 11, I think this is? We're okay? Yeah, I can do C. So if we're looking at C, now remember that's that one of those, it's in 12ths. So 12ths is in pi, and I'm just going to emphasize this as we're going through. This is 12 pi over 12. Okay, this is 24 pi over 12 if I finish it out. Okay, so that's why I'm going to look at it, and it's pi 12ths. So I'm going to take 2223 divided by 24. That's the first thing I'm going to do. Okay, so I got 2223 divided by 24. Okay, that's 92.625. Pull this over. I got 92.625. So that's 6.625, 62.5% of a revolution. Okay, in kind of radians, but I'm working with 24ths. Okay, so I'm going to multiply 0.625 times 24. Okay, and I get a 15. So this is 15 pi over 12. Okay, are you okay where I got 15 pi over 12? So down here, I'm going to go a full 12, and I'm going to go 3/12 more. Well, 3/12 is a fourth, right? Well, that's crazy, right? So that 3/12 is a fourth, so this is 15 pi over 12, okay? But they're asking me to do just my reference angle, and that's the positive angle. So I got to know I've got 15 pi over 12 minus my 12 pi over 12, which is 3 pi over 12, which is pi over 4 after I reduce. Okay, does that help as I'm looking at that? Are there other questions? Are we okay with 11? I think this is 11, problem 11. We're good? Explanation on things we've gone through. Is it making sense why I'm doubling that? Remember, if I didn't have this pi in here, and I didn't have and they still had 12s, I would still double it, but I just wouldn't drop the pi. And then when I got my answer back, I wouldn't put the pi back in because it was never divided out in the first place. Okay? It's just a trick to help me with my revolutions. Now, the conversions. The hand conversion to go from DMS to degree and degree to DMS. How are we doing with those? Questions? You want to see it again? I'm okay with doing it. I know I got it there, but I'll explain myself out and how I did it. We're good? So 13 and 14, here we come. 13, the conversion of that to DMS. Is that what we want to see? We're okay? Are we okay with going from radians to degrees and then to DMS? Because that's really what we're doing. Okay, and this one was kind of nice because it was nice and clean. There was 0 seconds, 0 minutes, 0 seconds, because there was nothing after the decimal point because it went in evenly. Okay, 14. Questions here? Doing okay? Claire? 14 better now? 14 and 15 were the big ones that we started class with. At least that was the intent until we went through 9 and 11. So did those clear up those questions? Or do we still have questions on them? So which one do we have? Gracie, what do you got? Yep, both of them? Okay, so 14 and 15? Okay, let's talk about 14. So I'm looking at find an angle theta. Now the notation means I want the angle, my answer, between 0 and 360. Okay, so I'm going to pull them back. A couple of them are kind of nice because I'm just going to, like 744, that's 24 more than 720. That's 2 full revolutions, right? And that's why I just decided to subtract 720. And I'm just asking that is coterminal with the following given angle. So I'm looking at this. Although the original is 2 revolutions and a little more, because that's supposed to be 744. Okay. How much more did I go? And in quadrant 1, the reference angle and the coterminal angle in this particular case are the same value. Okay. And all I did was 360 times 2 is 720. And I subtracted 720 to find my coterminal angle. That was between 0 and 360. That was positive. Are you okay with A? B. Still doing the same thing, except I'm going to do multiple revolutions. I could just be on my calculator all day and lose track of how many times I've subtracted 360 or added 360 to 5,000. So I'm just going to pop in my calculator. And for those folks that are wondering about it, I want you to be on your calculator too, so we can work this together. If you've got questions on how I'm doing it, it shouldn't be something like Olay and all of a sudden I come up with the answer. It shouldn't be a miracle step. Okay, so I got negative 5381.251 in my calculator. I'm going to divide by 360. I'm going to do exactly what I have set up there, dividing by 360. So I got negative 14.9479. Okay, negative 14.9479. You okay with what I got on my calculator? I'm dropping the negative 14. I'm just keeping the negative 9.9479 stuff after my calculator, right? I'm going to multiply that by 360 because that's how many total revolutions I have to find out what percent or what fractional revolution. Remember, it's 0.9. It's almost a full revolution left. So I just got to catch up in my calculator, times 360, and I get negative 341.251. That's what I get. Okay. So if I'm at negative, and keep in mind what this looks like picture-wise, I'm here, I've got a circle. My revolutions, they went around 14 times. I'm not going to put the donut in for showing that it went around 14 times. I'm going to show around, it went around 341. Okay, I'm like 18 degrees short of a full revolution, right? That way. And that's what this negative 341 plus 360 got it in the range from 0 to 360. So I could talk about it as a positive angle between 0 and 360. That's it. Are we okay with what I did there? Clarification-wise. We're good? I promise there's stuff like this on the test. Guarantee it. Any other? C, D. We doing okay? It's awfully quiet. I'm willing to work them. I'm willing to move on. Which one you want? The folks that talked to me beforehand, you okay with these? No. Okay. Anybody else have this? Even if you didn't get to it, I'm willing to do it again. I'm fine. D? Yep. Okay, so D's and DMS. Okay. remember how I talked to you about going from DMS to back to degrees? Okay, all you have to do is put this in your calculator. And you remember that these two are available. I should say that the symbols are available. I keep forgetting I'm not working on a smart board. I mean, in the smart program. You're going to go 800, 25, and 25. These two items available in your calculator under angle. Okay, so enter them into your calculator. You got 800, go second angle. Okay, enter. You got 800 degrees. Okay, 25, second angle. Go down to the minutes. And then this one is available over on the right above the plus sign. And you got to hit the green alpha button to get to it. Are you okay? You following along with it? You got a calculator to practice it? You should have a calculator to practice that. Okay, so that's 25 second double alpha. Okay. So that's what I've got. So find out where those came from. So you got 800, again, second angle to find that stuff. Okay, degrees. And you got 25, second angle. And you got 25 alpha. And then you just hit enter after you get that all in. After this is in your calc, you hit enter and you get this value. Okay, now I'm going to let you in on a really nasty, horrible thing. 800 is a little more than 2 full revolutions. That's why I subtracted 720. People think, well, you're doing them differently. Oh, just decided not to divide. That's it. I just took 720, 2 revolutions away, and I got that done. Does that make sense? Yes or no? Are you okay with that? Okay. And that's all I'm doing on those. But it's me being familiar with it. But again, I wouldn't, as I'm testing you, I wouldn't expect you to switch it from a DMS to degree by hand and then do a calculation. I would expect you to know the calculator moves to get it to that 800.4236111, and then what do? Okay, and I'm just taking away 2 rotations. 720 is 2 rotations I took away, and it brought it into the, because it was positive, it was going to be pretty nice. So that's where it's 80.424. And they only asked me to put it back in the DMS, so I didn't. Any other clarifications? You doing okay? Now, this next section is totally working with us putting it in radians. Okay? Is it making sense how to do those? Any questions? We're okay? Get some head bobbles here and there? All right. So I'm okay with the wheels on the bus dropping off, but we have a offshoot of the use of time. Okay? So part of today's lecture will probably be taped, and then we'll have to like cover it, because I need to be at a certain point, because you guys have a test Wednesday. And I can't push that off because you have another test another time, and I've got that all the way up until the final. Okay? So it's a need that we have to have on that. Yes, sir. 15D, sure. Okay, so if we're looking at this, find an angle between 0 and 2 pi that's coterminal with the following given angles. These are all in radian. There's no degree sign, okay? And they're telling me that my answer's got to be between 0 and 2 pi. Okay, so that's how I know it's got to be an answer in radian. So if I'm doing 20, okay, 20 divided by, remember, if it's in radian, I'm going full revolutions, and that's like 3 revolutions, a little bit more. And folks are like, how do you know it's more than 3 revolutions? Because 2 pi is 6.2 something. Okay, so 6 times 3 is 18, so that 0.2 is like 18.6, 18.8, somewhere in there. So it's short of it's more than 3 revolutions, big. That's how I know that. But I'm looking at that 20 divided by my 2 pi. I can actually not have fat fingers and push my buttons correctly. So I get my 3.18. So this is actually 3.1830988. So I take off the 3 and I go, hey, I'm going to multiply 2 pi times 0.183098 in my calculator. Okay, times 2 pi. So I get 1.15. That's where I'm going, my 1.150. Okay. And that's my coterminal. Does that make sense? What I'm doing with it? Now, I can promise that the difficulty level of this semester is really working with radians and being familiar with having that idea of what happens with it. Okay? Yeah. Yep. I get 1.15044. Multiply the pi in. So I multiplied it in. So if you want to put it over, if I want to put it over the way I did in the problem, divide out the pi from 1.5005. So I got to divide that out. If I divide out that pi, I get 0.36619, and that's where this 0.366 pi comes from. Because if I take that 0.366 pi and multiply it, I get 1.15. Because I've got to be comfortable with being able to realize that at this point, I multiplied the pi in, so this has pi inside it. The pi's in it. It's like it ate it. It's not sitting out on the side of it. Okay? So I have 2 versions of my answer here. That's why I have theta alpha coterminal being the 2. And on this one, I'm not adding pi. This is 2 times pi. Yeah, but yeah, I could just multiply by 2, and that's where that 3.66 came from. Okay, and then pop in the pi on the side. Okay, I see where you're going there. Yes? We were just talking about it. Okay, yep. So are you okay with multiplying 2 pi times this? Okay, and are you okay that this is 1.150? What if I didn't multiply the pi? What if I multiplied 2 times 0.1830998? What would I have gotten? Okay, so 3.66 pi is an equivalent statement as 1.150. Okay, it just depends on how I want to house the problem. In terms of pi or not. Okay, and because it was between 0 and 2 pi, kind of pushed me to put it in pi that way, but this is also acceptable unless I say something else. You all right with that? Okay, don't want it to be a miracle step. Okay, but it is about fractions and you getting more comfortable with our radians. Okay. Any other questions on that? Doing okay? All right, so let's at least look at what we've got for going today. Thank you for the questions. What we're looking at today. You guys have PreCalc section 4.2. I'll probably have taped the second part of this today, this afternoon before, or tomorrow morning, and you guys will get the 2 days of notes in one grouping, so you guys be able to look it over. You're going to use right triangle trig. You've done this, 45, 45, 90, 30, 60, 90. This stuff is from geometry. Okay, work with the 2 famous trig triangles. Hey, 45, 45, 90, 30, 60, 90. Evaluate trig functions with your calculator, knowing that you have to be in radian or degree depending on the angles you're working with. Apply right angle trig. Okay, now right angle trig, similar. Same shapes, but different sizes. This means all angles are congruent, but corresponding sides are proportional. One of the most basic similarity postulates is AA. When we're talking about right triangles, we already know that they have a set of right angles congruent. Therefore, we only need to know that the one set of acute angles are congruent in order of the triangles to be similar. And that's the acute angles. This is the two angles that aren't the right angles. Okay. This one acute angle determines the 6 trig ratios for side lengths of the triangle. To make our computations easier, we often use acute angles in standard position in the XY plane with vertex at the origin. Okay, and remember this is section 1, 2, 3, 4. If I'm working in one, I got a plus plus. They're positive x and y, negative x, positive y, negative both x and y. In quadrant 3, and in quadrant 4 it's a positive x and it's a negative y. Okay, so we're starting out with standard position. We'll be making our angles in standard position to get used to it and see what's going on. Now, you guys have worked with hypotenuse, opposite, adjacent. Our definition of our trig functions are here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite adjacent. You may not have, if you have a Inspire calculator, you probably saw a cosecant, secant, and cotangent. You've probably seen them before. But they're written up here because of the way they're related. Okay? They're written up here. We have the sine opposite over hypotenuse. We have a cosecant, hypotenuse over opposite. They're reciprocals of each other. That's why I can say it's 1 over sine theta. Okay? Cosine of theta, okay, is adjacent over hypotenuse. The secant is hypotenuse over adjacent. They're reciprocals of each other as well. 1 over cosine theta. Tangent and cotangent are reciprocals of each other again. Okay? They're related that way with reciprocals. They're also related by being co-functions of each other. Okay, and we'll talk about what those co-functions are. But to use a calculator, you must know these this way unless you already have the fact that your calculator, if it's an Inspire, has the cosecant, secant, and cotangent, because the other calculators do not. Okay, so you've got to know that relationship. Now, part of this, when we're looking at this relationship stuff, there's twice as many trig functions as there are triangle sides to define them. So we can already explore some ways in which the trig functions relate to each other. Doing the exploration will help you learn which ratios are which. See, each of the 6 functions can be paired to another that's its reciprocal. So sine of theta, based on the stuff we just did, okay, we should be able to have opposite of hypotenuse, cosecant. Now, every time I write these, I go sine of theta, cosecant. I go cosine, secant. I'll go tangent, cotangent. Okay? I always write them across from each other when I'm doing this so I can actually be more efficient with finding the inverses. Okay, because they're just reciprocals of each other. Cosines, you know, if you remember your basic sine, you know, you had SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangents opposite over adjacent. So if you just get those written down, you know that the other ones are the reciprocals of that. And we have that going on for us. Now, which trig function can be written as the quotient of sine theta over cosine theta? Well, sine theta over cosine theta is kind of some manipulation that we've got going on. Remember, sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. Okay, well that's the same as opposite, suppose I put in a third P there, over hypotenuse times hypotenuse over adjacent. Well, my hypotenuses cancel, and my final answer would be opposite over adjacents. Okay, just using fraction multiplication. I'm just using properties of fractions. This division, same as multiplying by its reciprocal. That's what I did there. So sine theta over cosine theta is just opposite over adjacent. Well, which one's opposite over adjacent? Tangent. That's the same as tangent theta. Now, there's a lot of fraction manipulation as far as the way it's defined. Okay. In our third one, which trig function can be written as a quotient cosecant theta over cotangent theta? You okay? Novotny, you got them all done? I don't want to get in everybody's way. You guys got them done? Oh, we got about 8 minutes. We'll finish this and then we'll slide on the remainder tomorrow. Okay, so if I'm looking at this, I know that, are you in agreement that I was able to pull those? That cotangent and tangent are reciprocal relationship to each other. Cotangent is 1 over tangent and cosecant is 1 over sine. Okay. Now I can multiply that. I can say, well, that's 1 over sine theta. Okay. But 1 over tangent is the same as 1 over sine cosine. So I can flip it with that relationship. And all I'm doing is trying to knock some stuff out to get it down to the basics. When I'm looking at that, I've got tangent over sine. But tangent, we just found out, was sine theta over cosine theta. So I can flip those. Sine theta over cosine theta over sine theta. So now I know that this is the same as 1 over cosine. Because all I'm doing is flipping it. See, I just did everything on top the same. Times the reciprocal of sine theta over 1, which is 1 over sine theta. So because of my fraction properties that I'm working with, now I'm just multiplying and dividing. Sine thetas knock out. And if you're wondering what second semester is, this is a lot like our first 8 weeks, especially when we get to chapter 5. We're doing trig functions. We're manipulating one side using fraction, multiplying, dividing, and properties to make another value. And actually just reduce. So this is 1 over cosine theta, but I learned that 1 over cosine theta above was what? What's the reciprocal of cosine? Secant. Okay, so this should be secant when I'm done. And I know I stepped through it, but I wanted to make sure everything was shown, how I was able to go from part 1 to part 2. Okay. Now, in step 4, they ask, what is the simplified product of all 6 trig functions multiplied together? You got to be thinking about this. Do you have like a prediction? Because aren't they reciprocals of each other? Like cosine secant is secant's 1 over cosine. Cosecant's 1 over sine. Cotangent's 1 over tangent. So if I have a bunch of reciprocals multiplied together with the regulars, what's going to happen with them? They're going to knock each other out and become 1. At least they should. Okay, if I'm stepping through, this becomes sine. That'll knock each other out. Cosine, that's 1. This will be 1 as I'm looking at that. So it should just be 1 when I get them all done. Okay, but it's not good enough for me to say, well, it's 1. I've got to show why it's 1. Okay, so algebraically, I've got it set that it's 1. Any questions about the algebra on those. Okay. Now my last question that we're going to be covering today. Which two trig functions must be less than 1 for any acute angle theta? Okay. And I'm not sure if you paid attention to that when it was an actual question that we asked when we were in geometry as 10th graders or 9th graders here, but it's sine and cosine. Okay. And the biggest reason is they've got to be less. They'll return values less than 1 for any acute angle. Okay, remember sine and cosine, we're talking about acute angles with them for right now. And we'll cut that off today right here. Thank you for your questions. I greatly appreciate it, and I hope I clarified those. And for the folks that had to ask follow-ups, thank you for doing that. But make sure you focused on what's happening. And I've always had people who are thinking, oh, you know, this is so hard, it can't be tested. It's tested, and it's not as hard as you make it by not practicing them. Okay, just make sure you're practicing them. Make sure you're putting in the time. Make sure you're clarifying questions about how to do things. Make sure you're going through the painstaking process of correcting your work online and handing it in class as well. Okay, thank you very much for your time.